The sales in thousands of a new type of product are given by S of t, where t represents the time in years. Find the rate of change of sales at time t equals 3. Okay, so we're asked to find the rate of change of sales, and we're given the sales function, so take the derivative. Okay. So s prime of t, when I'm taking the derivative, I'm going to have to use my general exponential rule. So remember, when I got the derivative of e to the x, that's just e to the x. But if we have e to the u, where u is a function of x, then the derivative will be e to the u times u prime. Okay, so coming over here, taking the derivative of s t, the derivative of 100 is 0, minus 60 times, and then I get e to the negative 0.8t times the derivative of my exponent. So times the derivative of this here, we get negative 0.8. Okay, and then cleaning this up a little bit, I've multiplied the negative 60 by the negative 0.8, and I get 48. So this becomes 48 e to the negative 0.8t. And now I can evaluate it at any time. So s prime of 3, plugging in a 3 for t. Crunching the numbers on my calculator, I get 4.354, a bunch of digits. And so running this to the nearest tenth, I will have 4.4. And once again, we gotta figure out our labels. So that we're told that the sales in thousands of a new type of product, so that's my sales in thousands, and then my time is in terms with years. So my label is going to be thousands per year. All right. Number 19, let's see, another application. So the concentration of a drug in the bloodstream t minutes after swallowing a pill containing the drug can be approximated using the equation C of t, where C of t is the concentration in arbitrary units and t is in minutes. So find the rate of change of concentration with respect to time at t equals 12 minutes. So again, I'm finding the rate of change, and it's going to be at t equals 12. So I'm using my general power rule to take the derivative. So I have c prime of t is equal to 1/6 times, I'm supposed to bring down my exponent, bring down the negative 1/2, decrease the exponent by 1, so 4t plus 1 to the negative 3/2, and then multiply it by the derivative of what's inside, so times 4. All right, cleaning this up, I would definitely recommend that you simplify it, but you could plug it in your calculator. So I can multiply, here the 6 and the 2 are both in the denominator, so this is going to give me a negative 1/12, and the 4 is in the numerator, so I get a negative 4/12. And then I'll reduce that fraction, so c prime of t is going to be equal to a negative 1/3 times 4t plus 1 to the negative 3/2. And now I can go ahead and evaluate it for 12. So I have c prime of 12 equals negative 1/3, 4 times 12 plus 1 to the negative 3/2. Computing what's inside here first, that gives me 49. So now I need to have 49 to the negative 3/2. And like I said, you can plug that into your calculator to get the answer. Remember that the negative means you're taking it in the denominator, and then the fraction exponent, I've got the square root of 49. And like I said, that's going to be cubed. So I've got a negative 1/3 times 1 over 7 cubed. And this will give me a negative 1 over 1029. And again, that label thing. So coming back up here, we know that the concentration, so C is measuring the concentration, and it is being measured in arbitrary units, so just going to be in units, and that the time is in terms of minutes. So my label here is just going to be units per minute. And yes, you can use abbreviation for minute, hour, anything that's, you know, commonly used. You can use those abbreviations. Number 20. So a pen manufacturer determines that the total cost in dollars of producing X dozen pens in a single day is given by C of X. Find the marginal cost at a production level of 70 pens and then interpret the results. All right, so we are asked to find marginal cost at a production level of 70. So marginal means take the derivative. So C prime of X is equal to 2 minus 0.02x. And now we will evaluate this when X is a 70. So let's see, we get, that will be 0.6. Okay. We're going to have to include labels. This one also said interpret it. So when we go back up here, notice that the total cost was in dollars, and we were producing X dozen pens. So this is going to be, my answer has to be in terms of dollars. So convert that to, I would just write it as 0.60. You could say 60 cents, but I would write it this way. And it's going to be per dozen pens. All right. So as far as interpreting it goes, I would just say that, you know, my marginal cost is 60 cents per dozen. And then, like I said, it's interpreting it. Marginal cost, it's telling you, think about it as it's telling you about the next one. So, you know, it is a derivative. So it's the derivative when I made 70. So that's the rate of change is telling me what happens right after 70. So it's kind of an estimate of what's happening between 70 and 71. So then I could go ahead and say that the cost to produce the next dozen. So the cost to produce the next dozen and since, you know, I'm at 70, the next one will be the 71st dozen, is 60 cents. All right. Number 21, we are given the profit function, and we're asked to find the marginal profit at X equals 5. So marginal profit, very similar to what we just did. Marginal says take the derivative. We have our profit function. So P prime of X is equal to 8X minus 5. And now evaluating this at X equals 5, we get 8 times 5 minus 5. So we have 35. All right. And then I should go ahead and include my labels. Notice that the profit is in terms of hundreds of dollars. So I would say marginal profit is $3,500, and that'll be per item. Number 22. The mathematical model for the average of a group of people learning to type is given by N of T. And N of T is the number of words per minute typed after T hours of instruction, where they practice 2 hours per day, 5 days a week. What is the rate of learning after 50 hours of instruction and practice? So the rate of learning, take the derivative of the learning function. So N of T is my, measures my learning. So N prime of T, take the derivative of 10, get 0 plus 6 times, and then the derivative of the natural log of T is 1 over T. So simplifying this, I just get 6 over T. And now evaluating it when T is 50. So we get 6 over 50 which is 0.12. This is a positive number, so it's an increasing rate, but it's also a pretty small number. So what's my label going to be? Okay. So remember that my rate of learning, N of T, is the number of words per minute typed. So N is going to be the words per minute typed. And what does T measure? T is going to be the hours of instruction. So my rate of learning is going to be 0.12 words per minute typed per hour of instruction. And you could say practice and instruction. All right, it's a nice long label. Okay. Number 23. Okay, so on number 23, we're given this graph, and it shows the stock price of a new internet company over the first 18 months after initial public offering of its stock. Notice in the table that the stock price is here on the side, so that's going to be your Y value, and then the months are running across here on the bottom. So what is the stock price to the nearest dollar in the 14th month? So I'm asking you to find the stock price. So, I'm basically asking you to find the function value. If f of x, computed the stock price, if that were the stock price, then I'm basically asking you, what is f of 14? And this is just a point we have to read off the graph. So when x is a 14, so looking at this month here, I go up till I hit my graph. And then looking over here, it can't be precise, but it looks to be about 35. So I'm going to go with $35. If this were a multiple choice question, I'd make sure that I wouldn't give you like 33, 34, and 35 to choose from. And if it was a free response question, I would be pretty generous. Anything close to 35, I would give you credit for, because it's clear that you're looking at the right part of the graph. Number 24, I'm given some information about manufacturing toilets, and I'm asked to find the total cost of producing X new toilets, and also to write the revenue function. So total cost is going to be the sum of your variable cost and your fixed cost. Your fixed costs are things that don't change, like maybe your rent, regardless, of how many units you make, and then your variable cost will fluctuate with the number of units. So up here, I'm told that I have fixed cost of $16,600 and variable cost $69 per toilet. So my cost function, C of X, where X is the number I'm producing, is going to be 69X plus 16,600. Now I need to find my revenue function. Revenue measures the money coming in. So you can think of it as quantity times price or demand times price. And so that will be X times P. X is the demand and P is the price. So up here we're told that they sell the toilets for $150 a piece. So R of X is going to be equal to 150 times X. 150 is our price and X is demand. So these are my cost and revenue functions. Now the next question, number 25, same numbers, but this time they're asking us to write a profit function. So profit is going to be, all the money that you're bringing in minus your expenses. So you should think of that as revenue minus cost. You can, we already wrote the functions up there above. I'm going to go ahead and just rewrite them here. You can just use our results from above, but just a quick reminder, our revenue, since we were selling the toilets for 150, our revenue was 150x. And then we need to subtract from this our cost. And so our cost function, we had 69 per toilet, so 69x, plus, and then our total cost, $16,600. The main mistake students make on this one is not distributing the negative sign. So I want to rewrite it out. 150x minus 69x minus 16,600. And then combining my like terms, we end up with profit is equal to 81x minus 16,600. And that's my profit function.